This lesson shows you how to use place value to understand base 10 relationships between millions and thousands. Now, with these lessons, it's important to understand a place value chart. As we look at the chart, we see that it is in what we call base 10. That means if we have 1, 1, it is 10 tenths, or 10 ones is the same as 1/10. Everything here is in multiples of 10. So as we go from right to left, that is multiplying it by 10. For example, if we have 10 ones, we really have 1 10 and 0 ones. Or if we have 10 tens, we have 100 and 0 tens and 0 ones. Now what I didn't do, which I should have done, was write a 0 in the 1 section, which helps us identify that if we give each number its own square, we have a 0 ones like below, we have 0 tens, and 100. At the same time, when we go from left to right, for example, tens to ones, we are dividing by 10. So if we have 1 10 and 0 ones, and we divide that by 10, really we have 1 1. Then let's explore it a little bit more. So if we have a number like 1 million and we divide it by 10, we're going to start by writing our 1 in the million section. We don't have any hundred thousands, 10,000s, thousands, hundreds, tens, or ones. And now what we're doing is dividing by 10. When we use a place value chart, all we need to do is move it to the right one place, and we can move all the other numbers to the right one square in the row below, which shows us that we then have 100,000 as our solution. And that's all that you need to do when you have the place value chart. If necessary, we can continue to add zeros in the tenths, hundredths, and thousandths because it is after the decimal point. Before the decimal point, we don't add anything. Now, typically when we think about problems like this, we think about moving the decimal point. But when you look here, you see that we're actually moving the number, we're not moving the decimal. And it's important to remember that as we go through the next few lessons. One way that might help you remember this is if you think about money. Have 1 dime, which is the same as 10 pennies. Okay? If we have a dime, we can say what is 10 cents divided by 10, which is, or 10 cents divided by 10, but we know we only need 1 penny. So 10 cents divided by 10 is 1 penny. Okay? We can also look at that with more money in the sense that we have $1 is the same as 10 dimes. So if we have $1 divided by 10, we have $1 split into 10 dimes, which is 1 dime. So what if we have a problem? 6 divided by 10. The first thing that we need to do is to write 6 in the ones place, because we know that there are only 6 ones. It's not 60, it's 6. And we have 0 tenths. Then all that we need to do is move our 6 one place to the right, because it is division, and we'll see that we now have 0 ones and we have 6 tenths. So 6 divided by 10 is the same as 0 and 6 tenths. What if we change that number so that there's a decimal? Let's try 6 and 5 tenths divided by 10. And note that it's important to say it properly, 6 and 5 tenths, not 6.5. So then we have 6 ones and 5 tenths. We still go through the same process where we slide that number 1 space to the right. So now we have 0 ones, and the decimal here means and, 6 tenths and 5 hundredths. So 6 and 5 tenths divided by 10 is the same as 0 and 65 hundredths. Okay. I want you to try this one quickly on your own. 6 divided by 100. Keep in mind that if we go 1 space is the same as dividing by 10, how many spaces might it be if we're dividing by 100. Try it on your own and then I'll show you. Okay, when we look at this going from, instead of by 10, we're going by 100s, we need to move it 2 places. And one thing that can help you remember that is that there are 2 zeros after 100. So if we're going by 1,000, you can go 3 spaces. Looking at the work here, our 6 ones moves 2 places, which is 1, 2. So we put 6 in the hundredths. You notice that we have a 0 in the tenths now. That's because we cannot leave a gap, because that would, if we left the gap, it would automatically move the number over to make it 6/10, which would not be the case. So our solution of 6 divided by 100 is 0 ones and 0 tenths, but 6 hundredths, which is read as 6 hundredths. What about multiplication? Try this one on your own. 4 tenths times 10. If we're going to the right for division, what do you think the opposite might be? To solve this one, we do it exactly the opposite of division. We're going to slide every number to the left 1 space. So we have 0 tens and 4 ones. So 4 tenths times 10 is the same as 4. Now, for multiplication especially, when I look at decimals, I think in terms of money. So we can have 4 tenths being the same as 40 cents or 4 dimes. So the way that I would look at this problem would be to look at it with money, where you have 4 tenths, which is 40 cents, times 10, or 4 dimes times 10. And when we take that, we then get 40 dimes, because 4 tenths times 10 is 40 tenths, or 4 dimes. And we know that there are 10 dimes in a dollar, so if we split them into groups of 10, we know we have $1 in this row, $1 in this row, $1 in this row, and $1 in this row, for a total of $4.00. You can see that on the place value chart as 4 tenths times 10 is 40 tenths, and really we don't want to leave that 40 in the tenth section, so what we're doing is we're sending over the 4 so that the 0 can have its own space. Okay. What if we have a problem like 4 35 hundredths times 10? Try this one on your own, and then I'll show you. First thing we do is write down the number, and since we're multiplying by 10, we have 1 space to move it. We then end up with 4 tenths, 3 ones, and 5 tenths, which is 43 and 5 tenths. We can look at this the same way when we're multiplying by 100. Remember, it's 2 spaces. So again, we start with 4 35 hundredths. We're going to slide it 2 spaces because it's 100, which gives us an end solution of 4 hundreds, 3 tens, and 5 ones for a total of 435.